Hi and welcome to my first video about muscles, and today we're going to be looking at muscle fibres and the structure of a muscle. And so the first thing we're going to look at is the overall structure of a muscle. And so you're probably all familiar with the joining of a muscle to a bone is formed for a tendon. You've probably all heard of that before. A ligament, that joins bone to bone, but a tendon specifically joins a muscle to a bone. Some of these other terms you might not have seen before, and they're not strictly essential for the AQA PE course, but I'll go over them anyway. If we start with the smallest subunit here, so a single muscle fibre, a single muscle cell. If you have several of those muscle fibres grouped together, we refer to that as a fascicle. And around the outside of several essentially fascicles, or around the outside of a fascicle, is wrapped by a layer of connective tissue called the perimysium. You also have spanning in between the individual muscle fibres. You have a structure called endomysium, which again is a connective tissue, but that runs throughout the middle, hence endo. You'll have the epimysium, which goes around the entire outside of the entire muscle, and so that wraps in all of the fascicles and therefore all of the perimysium inside. And the muscle fibre itself has a huge network of blood vessels, and so therefore it can supply enough blood so that the muscles can continue to work even under high stress. Now, going into an even smaller subunit, this is the smallest subunit we have labelled here, which is a muscle fibre or a muscle cell, and that can be broken down even further into smaller parts. And so what that looks like is this structure. And so there are loads of these structures called myofibrils, and these myofibrils basically composite and they add up to make an entire muscle fibre, and they're wrapped around a kind of membrane called a sarcolemma. And you can see here that you have a nucleus very much like you find in a typical cell. So the sarcolemma is very similar to the cell membrane that you find on a typical cell, and obviously contains a nucleus, sorry. And this is the subunits that are actually responsible for contraction. And these myofibrils break down into smaller sections, and they're made of essentially two major muscle filaments. One is called actin and the other is called myosin. And so these filaments can actually be seen here. So you have a thin actin filament and a thick myosin filament, and they're the things that are actually physically responsible for the muscle contraction. If we look at this diagram, it shows it a bit clearer. So when we look at a specific section of a myofibril, it breaks down into this, and this section here, these two lines here, so a Z disc, or is sometimes referred to as a Z line, that composite, or that makes up a sarcomere. And now you can see here you have these two filaments. One is in the middle here, which is the thick filament, and one is around the outside, which is the thinner filament. The thick filament is the myosin, and the thinner filament is referred to as the actin. Now, a decent way to remember this, or an easy way to remember this, might be that the thick filament is myosin, because myosin contains more letters than actin. Therefore, the actin is the thinner filament. You've also got, if you look at this sarcomere, you have these Z lines at the end, and you have one of them definitively in the middle, so the thick filament within the middle. And so the way in which I always remember this would be the thick filament, or the myosin, is found within the middle, M. And so I use the first letter of myosin to remember that that's in the middle. Now, what happens during a contraction is there's an interaction between the thick and the thin filament, and that's what we'll look at in the following video. There are also some other things that you can see labelled here, the A band and the I band. Now, if I go into a bit more detail about what those actually are, so this diagram really illustrates the difference between the A, I and the H zone. So if you look at our diagram, this represents our thick filament, our myosin, and our thin filament, which is the actin, wrapped around it. Now, the A band, what that shows is, if you look at it, the A band is always the thickness, of the width of the myosin filament. The I band only represents just where the actin filament is, and the H zone represents the distance between the two actin filaments. And you also have this measurement here, which is your sarcomere, which is the distance between two Z lines. What happens when you get a contraction is some of these sections shrink down. The A band remains pretty constant because the thickness of the myosin filament doesn't alter, but the I band, you can see here, has shortened somewhat because the actin filament has moved in. The H zone has all but shrunk, so there's now virtually no distance between the two actin filaments, and also the sarcomere size has also decreased. And so when you contract a muscle, it actually gets physically shorter. And so that's why, essentially, because that these actin and myosin filaments are interacting with one another. So to review, the H zone and the I band get smaller, and also the sarcomere gets smaller during contraction, and the A band stays constant. If you join me in the next video, where I'll be going through the sliding filament theory.